Oh, students, straight back again. Today we get section 13.3 Buoyancy. Here show a golf ball in some water. Forces from pressure acting on this golf ball are greater than those on the top. Produces a net force called the buoyant force that acts upward on the ball. So, showing top pressures. Smaller than bottom pressures. Pretty much side pressures end up canceling out. And we get a net upward force. The definition of buoyancy: ability of fluid to exert an upward force on objects placed in it, and buoyancy results in the apparent loss of weight of an object in a fluid. Every object in a fluid experiences buoyancy. Water pressure increases with depth. Forces pushing up on the bottom are greater than the forces pushing down on the top. This gives you a net upward force, or a net force, called the buoyant force, and it's like in opposite direction of gravity. And I get a thing called Archimedes' principle, and the buoyant force on an object is equal to the weight of the object weight of the fluid displaced by the object. As a submerged object pushes aside or displaces a volume of fluid equal to its own volume, a floating object equal to the volume of the part that is submerged. A key question: how can we determine if something's going to float or sink? And density helps us figure this out. If an object is less dense than the fluid it is in, it will float. If it is more dense, it will sink. When the buoyant force is equal to the weight, the object floats or is suspended. When the buoyant force is less, the object sinks. So we got two forces acting on every object in a fluid: weight and the buoyant force. Force of gravity equal to the object's weight, acts downward. Buoyant force acts upward. Object that has the same density as the fluid it is submerged in will be suspended. It will float at any level in the fluid. The buoyant force acting on a suspended object exactly equals the object's weight. Submarines and some fish are able to suspend themselves by adjusting their density. So, sinking. If a ship's weight becomes greater than the buoyant force acting on it, it's going to sink. As it takes on water, the ship displaces less water and the buoyant force decreases, and it's going to sink more. Solid piece of steel is going to sink in water. Heavy steel ship floats because of the shape. The hull is shaped so that it displaces a large volume of water, creating a large buoyant force. Buoyant force determines if an object is going to float or sink. Here, the weight in A, the weight is much bigger than the buoyant force, it sinks. In B, they're equal, it's suspended. In C, buoyant force is greater than the weight, so it is floating. The denser a fluid is, the greater the weight displaced, and the greater weight results in a greater buoyant force. So things float easier in more dense fluids. Why, you can float in a very salty body of water, like the Great Salt Lake or the Dead Sea. These are very salty bodies of water, and makes it very easy to float. An example of a ship when it has little markings on it to show how far it is riding above the water. And a few quick questions. And work at these, try to figure them out before I get to the answers. According to Archimedes' principle, the buoyant force acting on the object is equal to d weight of fluid displaced by object. It's a basic little definition. How much fluid is displaced by an object that is floating partially submerged in a fluid? And it's a volume of fluid equal to the volume of the submerged part of the object. How much is down, that's how much has been displaced. An unknown substance is suspended in water. What can be concluded about the substance's density? If it is suspended in water, its density has to be equal to the water's density. And a 10,000 Newton ship is floating in the Great Salt Lake. Here's those great dense bodies of water. Is salty water is denser than pure water? What is buoyant force acting on the ship? And we'll see C is the answer. Because it's floating, the buoyant force has to be equal to the weight of the ship. Otherwise it would sink. That's section 13.3. That's all for now.